Good morning, respected guests, the experts, and my colleagues. Many thanks for the conference team invite us to give a speech here. My name is Aiguo, and actually I'm from Yinwang Intelligent Company. Previously, we are intelligent solution, automotive solution business unit of Huawei, but now we are a subsidiary company now. We focused on um, developing and provide the products and solutions with for automotive intelligence and digitalization. Today, I'd like to share some our insights and practical experience with digital foundation for intelligent vehicles. And automotive are accelerating the evolution towards the intelligence, as Mr. Zhang said in previous slides. And also the digitalization is very important, and also shift to software-defined vehicles. But the most important requirement is intelligent drive. I think for me, every day I drive my Auto M9 from my home to the company. It now it's AR level, but actually the experience I think is more achieve the L3 level. I can when I go to my car, I just press the one button, it can drive from my home to my company. So the intelligent driving can bring the better driving experience and more safety for me and save some of my time. And another important technology just by why technologies. Mr. Zhang said that it's strict connect to the autonomous driving. Actually, this year, in China market many vehicles were equipped with the SPW, EMB, and also 4 active suspensions. So this technology will be better performance and better driving experience. And another thing is the software is very important in the smart vehicle. So we need a high efficient development tools to help our customer or provide a better software to my customers. So we think in the uh, uh, with the technology and the intelligent driving requirements and also the high efficiency development requirements. So there are many demands on the software and hardware. I list here, for example, with the new technology, we can do some cross-domain connected control. The new chassis technology will enhance the vehicle performance and the driving experience, and also the AI chassis. We think the chassis will, with the technology growing, we can use many AI technology to enhance the intelligence both in vehicle and the cloud. Also to improve the driving safety and control the vehicle experience. And another thing is you should maybe we need to do something to architecture, reorganize our software architecture. So we think the full service oriented and the development is very important to the vehicle software. Another thing to the another domain to the hardware domain. So the first is with the intelligent driving requirements. The computing power will growing very quickly with the computing power of the chip and with several times has in 3 years. And another thing is the latency. You know, we get many data from the cancers and give the instruction to the actuators. So the communication temperature will be very important in the vehicle. And another thing is the safety. We need to do some redundancy or some other technologies to make the hardware and software do not have the issue do not have the issues. So because I mentioned some requirements from the past slides. So I think we released intelligent digital vehicle platform solutions. The concept is that we have a scalable hardware platform. So we use our Zuno VIU and central computing to 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 catch the requirements of different vehicles. And also we designed a unified software platform. Also it's have the SOS stack, and also we provide the vehicle management framework. Also, yeah, with the operating system we compare with the AutoSAR. And the for the applications we support the body and motor control suspensions and steering and braking system. Also, we have the cross domain and connected control experience. You know, Huawei has years of the experience on the ICT area. So I mentioned in the last slides the computing and communication technology is very important in future vehicles. So we redesigned an architecture. We call it communication and commuting architecture. So we, with the CCA architecture, we centralized the many functions in the central computing equipment. Also, we provide I mentioned the tool chain is very important to the software development in vehicles. So we provide end-to-end HOS Studio tool chain solution. And to truly achieve the central computing architecture, when we designed a 6-in-1 integrated architecture, it means that I mentioned in last slides, and we integrated body control, thermal management, and the motor control, suspension control, also the steering and braking control software in one car computer. We call it VIO 0. And all these functions we have running with this architecture. We cut many ECUs. This is just some our experience in average. Each car we can cut maybe we can reduce the 30 more than 30 ECUs, and also we can reduce the MCU payload. So with the and also, more importantly, through the innovation in architecture, it's possible to develop the cross-domain innovation features and software more quickly, and also bring the high performance and better user experience I mentioned in the first slide. And for consistency in architecture functions and user experience, the platform should support different vehicle models at various price. For example, we have from the 100,000 Chinese yuan to the 1 million Chinese yuan vehicles. We hope that we can keep the same architecture, also include the hardware and the software platform. Also we need to support variable vehicle models, for example sedan, SUV, MPV, and also wagon, and also the powertrain and types for BEV, REV, and PHEV. So all this hardware equipment is different. We designed the unified software platform to support the different vehicle models. So we think the architecture is very important. For example, maybe the economic car, we just use one hardware equipment. For the luxury level, we use 4 VIUs. But all the software is maybe we have the software, same software platform, and also the same software applications, but it depends on your hardware equipment. So I mentioned before the service-oriented architecture. We think it's very important for the intelligent vehicles, because the traditional architecture, we use the one ECU have one functions. So it's tighter coupling of software and hardware, and also the minimal changes involves everyone, maybe the tier one and the OEMs and some other suppliers. So we call it's a solid development, means that the software and the hardware is complete, and also it's hard to reuse the software across different models. Also, I mentioned from the cheap car to the luxury car, and we hope that we can build a architecture like the right side. We have unified the hardware, we have unified the software platform, and we use the um, platform to support the different software functions. But we think or we hope that the architecture should be more flexible, accurate, and agile development and domain cross domain reusability. So we designed it use the SOA architecture. We can get the benefit of agile development, rapid integration, and also shorten time to market. In the field of software domain, the concept of standardization and platformization are very important, we think. So this our software platform architecture. It commanded by four parts. The first is the autonomic service. It's decouple the application software from the hardware and enabling seamless cross-domain, cross-platform software reuse, and enhancing system scalability across device vehicle models. And another layer is the device abstraction software layer. This layer addresses the hardware definition among the vehicle models and enable rapid integration of device hardware. And another is the operating system. It's fully compliant with ORSA standard, and we have many optimization to the solutions. I mentioned in the past the solid architecture, the hardware and the software is complete. So we need to support many functions in one central car computer. So we need to reorganize or redesign the some uh, software to make it can catch the requirements. And also another important is we do many enhanced develop redesign the Ethernet protocols, because usually the traditional the normal Ethernet protocol is used for the ICT. They can't catch the requirements of the vehicle domain. So we do many enhance Ethernet communication efficiency. Also, we do some low latency and the deterministic communication technology in this area. And another thing is you need to want to get the software more easy to upgrade and more easy to use your remote technology to manage or maintain your vehicle. So we designed a vehicle management middleware dedicated for the vehicle level, such as OTA, VHR, and VHVM, and also the device management service. So make our engineering can manage our manager or maintains our vehicle remotely. And another thing is the studio tool chain. We provide end-to-end EA design and ECU software development tool chain. And the important thing is the enabling the efficiency parallel collaborative development between OEMs and the tier one. And even in tier one or OEMs, a different software team also need this technology, because if we do something one by one, the efficiency is very low. And all the software in our solution will fully compatible with ORSA. I list some components here. For example, the smart headlights and the radar and the camera and the lidar. Also the computers. We have three central car computers: intelligent driving domain controller, also the cockpit domain controller, also the intelligent vehicle control domain controller. All this software we compared with AUTOSAR. Some compared with the classical AUTOSAR, and some we compared with the adaptive AUTOSAR. The basic software we designed in-house is the VOS. It's intelligent vehicle control operating system. Also, we designed the dedicated operating system for intelligent driving, and also we reuse the Harmony OS for our cockpit system, and also the tool chain. Yeah. So this slide I just I mentioned previously the tool chain has studio and is very important. We designed the end-to-end and SOA and model-based tool chain, include the system tool. It's we can use it for the define the hardware and software components, and also include the communication matrix design and I/O access and configuration. Also the function distribution and deployment design. For the hardware architecture, it's just define the AUTOSAR's interface data type and also the SWC interfaces and so on. And all these tools we can generate the model, and we can transfer the model from one tool to another tool. And some tool is optional, some tool is mandatory. Yeah, I mentioned that we want to get to the high efficiency development. So we do some things because currently we use the traditional way to develop the software between different team and between us and the OEMs. It's very low efficiency because if you change the DPC or some other data type or SWC interfaces, you need to redesign your software architecture and transfer your ARTML to the different team or from OEM to tier one. So we have many exchanges the data in it's very low efficiency. So and also the OEM heavily rely on the tier ones throughout the entire development process. So we architecture redesign the AUTOSAR and also redesign the software tools. So we hope that the different team and also the OEM and the tier one can do their development from the DPC phase and to the BSW configuration phase, also the code generator phases. By their we all do not affect each other. So the advantage of this solution is that the both OEM and the tier ones can develop software independently and also reduce the interaction with each other. Even in Yinwang's inside of Yinwang, we have different software team. They also use this technology, which it will increase the software developer efficiency. So we hope that we can get to the parallel collaborative development, and also we using technology. We release our platform to our customer. This is my last slides, and also to enable the rapid integration and the innovation in intelligent vehicles. And I think the IDVP provides the standardized SOC and northbound interface to the cockpit and the intelligent driving system, also the vehicle cloud. And also we designed the standard northbound interfaces connect to the sensors and actuators And I mentioned we designed a 6-in-1 integrated architecture. Is a powertrain, suspension, steering, and braking, or the thermal management system, and also abstract. I mentioned the many actuator and sensors. So we hope that we can uh, this can achieve the software and hardware coupling, and with the software reuse to different vehicle models, and also provide the end-to-end the tool chains. So for chassis control functions, we support cross-domain collaborative control and innovation. Implements chassis by Y functions through the zonal and centralized architecture, and also provide redundancy, safety, and high precision motion control. And with the service-oriented architecture and the layered decoupling and the standard architecture, and the interface with the end-to-end MBD and SOA tool chain, the custom inside in one team, or also collaborate with our customer, we can do the parallel collaborative development. So and we hope that this interfaces and this interface can be the standard. So we collaborate with many OEMs and many tier one in China. We are trying to standardize the interfaces. So we hope that we can co-build the open ecosystem to make the vehicle more easy to move from the traditional vehicle to intelligent vehicle, or in the future the AI defined the vehicle. So this is our goal, and also welcome everyone to join the builder and build and creative this ecosystem. And this is my last. Well, I hope you use our vision to end my slides to bring the intelligence to every vehicle for a safer journey and a better life. Thank you.
Thank you very much. Wonderful. Very impressive. I just saw your vehicle at one of them. I mean, I saw you have many you're involved with at the China Auto Show. I was sitting in the Maxtro,
Okay.
and I noticed this car maybe is known in China, but in Europe it's not known yet, but it was very impressive. I heard the brand started in 2023.
Yeah.
You launched in 2024, and last year this vehicle sold more than S-Class, Audi A8, and 7 Series together. So very impressive. Okay, so the floor is open for questions. So raise your hand, and we will pass the microphone to you. Does anyone have a question? It's almost equal, so maybe you saw who was faster of the two.
Thank you very much for the presentation. My name is Maite from Omdia. What I'm thinking is, what you're showing is really impressive. How do you perceive the value that the OEMs can add to the customers? So because that's the question, right? How much we standardize the platform, and where do the OEM add your unique value point? So do you think that there is enough space, and how can they do it?
Can you translate? I think he's looking for helping on the question.
Actually, I think in China, even some other European OEMs, they are welcome to. They are do many things, effort in this area, and we have organized organized team. We are do the centralized interfaces, and more than 100 OEMs and tier one join this team. So they are hope to build the open ecosystem to standardized sensors and actuators, and also provide the standard interface to the we call it upper layer application software, also include the cloud system. Yeah. So this architecture, I think, in China or in globally, the OEM welcome this architecture because it's an open architecture. Yeah.
Good morning, Alessandro Sansonetti from ST Microelectronics. I saw very impressive automotive architecture shown in your presentation. And you say that you would like to reach a kind of hardware uniformity, means that you would like to have the same set of ECU distributed over the full fleet for your vehicle. How do you grant it, and which is your plan to have this unique hardware distributed over the full set of vehicle that you are designing?
Okay, thank you. Because we use Lunar VIO and the central VIO. The VIO can direct connect to the sensors and actuators, and many issues are reduced, and so we can use VIO to direct to control the motors and get the data from the sensors. So many issues were reduced. So and the software are moved from the distributed ECU to the central computer. So for us, it's easy to control the sensors and the actuators. And also, I mentioned we abstract the device abstracting software and also provide the standard interface to the upper layer software. So it's actually this architecture more like ICT software architecture. So I think the standardized the software platform and also the standard interfaces and the scalable hardware is very important for the future vehicles. Yeah.
那个我有2个问题啊，第一个我看到你里边提到那个 RCP，第一个问题就是 RCP， 你认为什么时候会变成一个整车厂的电子电力架构的主流的趋势啊？这是第一个问题。第二个问题就是上了 RCP 之后，现在区域的控制器都在融合，把很多功能，比如说动力总成和底盘放在一个 SOC 里边去，对吧？那这个对这个底层软件有没有你看到带来一些挑战？这些挑战是否我们在这个 AutoSAR 的这个 standard 里边，或者已经考虑进去，或者哪些还没有考虑进去，能不能分享一下？
我就用中文讲嘛，就是实际上 RCP 这个技术，我们的产品都已经上，就是我们的当然跟标准的 RCP 可能不完全一样，我们的这个理念技术我们早就已经应用了。就在现在，如果买我们鸿蒙智行或者是我们的就是各个合作的车企里面，有的或者说有的车企已经用这样的技术了，因为我们是刚才提到的，我们希望对于末端的控制器、执行器，我们是标准化的接口。然后另外就是我们的软件算法。第二个您的问题是非常好，就是软件算法都跑在我的中央控制器里面。实际上我应该在2021年参加奥特萨这个会的时候我也讲过，就是我们这个对于整个的奥特萨的技术软件是有很多的挑战的。比如说我们原来比较适合就是一个 ECU 里面跑大概可能就10几个 SWC， 你全部跑到中央控制器里面来，它会这个急剧的增长，它有几百个 SWC， 它们之间的交互相互的影响，包括对通信的这个要求，实际上我认为是要做很多的工作的。所以我的前面的那个材料里面讲的，因为我们自己开发了一套这个 Classic AutoSAR 的方案，所以我们的场景，我们的就技术软件跟我的业务能够很好的结合起来。我们内部实际上对于我的无论是这个技术软件还是我的工具链，我们做了大量的优化来满足我们这个场景的需求。然后有部分工作我们也在这个通过我们的参与这个奥萨组的同时，我们也提到了这个组织里面提了一些这个相关的这个诉求的。